used. This can be anything. It can be a virtual machine. It can be a cloud instance. It doesn't matter. A physical server. The real server is just a backend server. Okay? So, as you can see, there is a relationship between whatever you have in the backend server and the nature of your service. So if you have a web application that uses HTTP, you are going to have an HTTP service. If you have on this real server an FTP server, you're going to have FTP as a type of service. In fact, we have different types of services. We have HTTP and HTTPS, normally used by web apps. We have FTP or FTPS, because some web applications might use FTP to transfer files, which is actually not a bad idea, since this protocol is designed to transfer files. Then we have other types of services that are called instant SSL and redirect services, which we will see in a moment. And then we have custom services. All right? Now, custom services can be configured in the WAF because, again, you might have a mail server that, for some reasons, is sitting behind the WAF. Now, the WAF is configured in a proxy mode, so it cannot bridge the traffic to this mail server, so you have to configure it. So in that case, you configure a custom service that will only proxy the traffic to the mail server. That's it. It will not do inspection, nothing. It will just proxy the connection to the backend server. Again, you cannot use UDP traffic. So the WAF only handles TCP traffic. Okay? Now, how do we configure a service in the WAF? We go to Basic Services. All right. Then we have to give the WAF a service name, like, for example, pet store. Then we select the type, HTTP, HTTPS, instant SSL, we'll discuss in a moment. Then we will give it an address. This is the VIP, for example, 10.1.30.150. Okay, and then we specify the real server. Let's see what is the real server IP address of my pet store. Okay, so it's pet store 00. And it's 10.1.30.120. Let's see if I am using. Okay, I have to use 140 here, and I have to use 120 in the backend server. 10.1.30.140. Sorry, 120. Okay, I will add it into the system. All right. So now my service is configured. So if I now browse on this VIP, this is my pet store. Okay, and I'm going through the WAF. How do I know this? I can access my access log, which tracks down all the requests, and these are my requests that I just then generated to access the pet store. Okay, so this is how you actually configure a service. Okay, you just have to follow whatever can be configured in this little section. Of course, there are many things that you can configure in a service, and we will see them when we will do the application delivery module on day 3, and right now when we discuss about SSL services. Now, if you want, you can terminate SSL sessions to the WAF. Now, this is actually mandatory if you want to do traffic inspection in the WAF. So what is going to happen is that you're going to install a certificate in the WAF, and this is the certificate that is going to be used by your web applications. Okay, so it should be a signed certificate, a valid certificate, because this is what the web browsers will try to validate when they're opening the HTTPS session. So our users will then do the handshake with the WAF, and then the WAF will either transfer the traffic to the web application in HTTP or back to HTTPS. Okay? So if you just want to do SSL offloading, then you would configure an HTTPS service, and then you would use HTTP on the backend part. Okay, so you're offloading your backend service from the task of encrypting and decrypting the traffic. On the other hand, if you really are concerned about security and also your backend traffic should be encrypted, then you use HTTPS, okay, in the backend part. And I will show you how to configure this. Now, there are some situations where your web application is not written to use HTTPS. So if you analyze the source code of your web application, you will see that all the links that are written in the code are HTTP links. So what is going to happen is that you are browsing your web application, and then you click on a section, and then a pop-up window will appear from your browser and saying, be careful, warning, some of the content that are sent to this website will not be encrypted. Okay, you're leaving the HTTPS session. Okay, or you will see a broken shield or broken lock in Internet Explorer, in Firefox, in Chrome, and so on. This happens because sometimes web applications, even if you force them to use HTTPS, they're not designed to use HTTPS. So they will not use HTTPS. Okay, they will instruct the browser to use HTTP. Okay, now we can protect these web applications by using a service type that is called Instant SSL. Now, Instant SSL will allow you to basically protect a web application that it's written to use HTTP by rewriting on the fly the code of the web application. Yes, it seems impossible, but this is what it does actually. So this is what happens when you configure an Instant SSL service. The system actually will add two services that will listen on the same VIP. The first service is an HTTP redirection service, saying whatever you want to access is not here. You have to go to the HTTPS service. Okay, so first request is going to be an HTTP request. For example, the system will say no way, redirect to HTTPS. Then second request, hopefully it's going to be to the HTTPS service. The service will then terminate the request, and it will then forward the request using HTTP to the web server, because this is the only protocol that the web application understands. Then the web application will reply using HTTP again, and the web application file will start to parse the code in the response. It will literally read through the code of that page, and it will use a module that is called website translations, and it will rewrite all the code on the fly. Okay, so again, this is then forwarded to the HTTPS service that will then forward the response to the users. Okay, so this will basically rewrite the response body of an application to make it HTTPS compatible. Okay. Yes, there is a question, but data will be unencrypted in the backend. Yes, this is the way that the web application was designed. Okay, so we can protect the web app in the front end part. In the backend, maybe we might use HTTPS. Maybe, we don't know. It depends how the web application is written. Maybe we will break the web app if we use HTTPS. Okay. Now, if we use an HTTPS service, we can configure additional security modules for SSL in the WAF. Now, in order to understand these additional security settings, you have to have a very, let's say, sound knowledge of SSL and TLS. Okay, so I will just give you an overview of some extensions that you can use in the WAF, then it's your basically your job to then dig in to understand how PFS, for example, works, or HSTS. All right, but before we go into the first extension, there is a question. In the first, okay, so the question is, but the data will be encrypted to the backend. Yes, data will be encrypted to the backend. The first service is listening on port 80. Yes, this is an HTTP service, but this is a redirection service. Okay, so it's not terminating the connection on this service. What it's going to actually, yes, the connection is terminated. Okay. On this redirection service, and then a response is generated, and it's there. In the response, you have a 3 or 1, for example. Okay, permanent redirect. The WAF will then append in the HTTP header a location header saying, in order to access this web application, go to HTTPS blah blah blah. Okay, so it will redirect the traffic to the HTTPS service. Here, the SSL connection is terminated, the HTTP connection is terminated. Yes, the redirection is for all requests that wants to use HTTP. Okay, so whoever wants to use HTTP, the request will be redirected. Okay, it works like this. Okay, it goes back to the user. Exactly, so that the WAF will then force our users to use HTTPS. That's correct. Okay, so any request to our web app that uses HTTP will be bounced back, saying, no way, you have to go to HTTPS, blah, blah, blah. Then the browser automatically switches to HTTPS and then does the handshake and so on. Is it clear? Okay. Yeah, so sure. Please go ahead. There is another question. The question is, if we configure two services, an HTTP service and an HTTPS service, and the user tries to access our web application through the HTTP service, how do I force him to redirect to HTTPS? Well, this is done by using some rules that we will see tomorrow. Okay, that you can use, for example, allow deny rules that will basically deny the user to go to HTTP whatever, and it will switch to HTTPS. But in this case, if you don't want that your users are accessing your web application using HTTP, you don't configure that service in the first place. Instead of configuring an HTTP service, you will configure a redirect service. Okay, configuring a redirect service will allow you to do what Instant SSL does it automatically. Okay, so a redirect service listens on port 80, expecting HTTP, and then redirects to HTTPS, for example. Okay. Yes. After you select, you create a redirect service, you need to add the HTTPS service. Yes. So you create a redirect service and an HTTPS service. Pretty much what you have here, but this is done automatically by Instant SSL. In your case, you do it manually. Okay, but you will lose the web translation module. All right. So it's only valid. This is only valid for HTTP redirect and HTTPS. So the first extension that we're going to cover for SSL is called perfect forward secrecy, in short, PFS. Now, in order to understand PFS, we need to understand how SSL works. Okay? Now, we don't have the time to cover SSL because I think at the end of this week we will still be here talking about handshaking and so on. So what you need to understand is that if I am securing an HTTP conversation using TLS or SSL, which is the same, by the way, the same in principle, and somebody will be able to get the private key of my SSL session, this somebody will be able to read everything that I am exchanging with the web server. Okay? So essentially, this is what happened with the Heartbleed bug, where we could basically grab private keys from servers by using a vulnerability of the OpenSSL library. Okay. Now, what happened is that if you grab this private key, you are then able to decrypt the traffic, but not only the live traffic. You can use a sniffer like Wireshark to basically collect a packet capture, okay, to create a packet capture, and then afterwards you can use that private key to decrypt that packet capture. So as you can see, the problem is extensive, and this is basically valid for anyone that is using your web application. Okay, so this is the case. If Tommy is using this web application and I am using this web application, you are using this web application, if somebody gets his hands on this private key, that's the end of the story. All right, you will be able to read the traffic. Okay, what you have to do is change it. Okay, change the certificate, change the private key. Now, in order to prevent this, you can use perfect forward secrecy that will basically generate random public keys per session during the key agreement. Okay, again, I will not go into detail about this. What you have to know is this. You have two users, John and Tommy. All right. These two users wants to use HTTPS to connect to our web application. What the WAF will do is it will generate two public key pairs. Okay, so if somebody somehow will basically break this lock, okay, because he will basically steal this private key, he won't be able to decrypt the communication that Tommy is doing with this web application. All right, because this is a different key. All right. Now, in order to use PFS, you must establish the connection with a Diffie-Hellman elliptical handshake, okay, or DHE, and you must use elliptical ciphers. Okay, this is a part of cryptography. Everything that is not ECDSA will not be used if you enable PFS. Right? I will show you how to enable this later. But in principle, this is the concept. Different keys for different users. A key gets compromised, only one session is compromised, not everything. All right? Another extension that you can use is called HSTS. HSTS stands for HTTP Strict Transport Security. And this is also known as certificate pinning. Basically, what is going to happen is that when the browser will browse to a specific web application, the web application will then say, this is my certificate, and this is the only certificate you should accept. Okay? Now, this will also include a new header in the response that is called Strict Transport Security with a max age, for example, 36,000 seconds. Now, this will basically allow you to prevent man-in-the-middle attacks with HTTPS. Okay, so nobody can actually be in between you and the web browser and the web server when you are opening an HTTPS connection. Now, if you are going to, for example, browsing from Starbucks, somebody might present you with another certificate, and if HSTS is enabled, then your browser will say, sorry, can't do, that's not the right certificate. Okay, many companies are using HSTS, like Google, I think Apple also use this. So you cannot put an intercepting proxy so easily to then spoof an HTTPS connection, okay, to do the man-in-the-middle attack. Also, this will break most of the HTTP proxies, web proxies. They won't be able to do SSL interception anymore, okay? Why? Because now certificate pinner will say, hey, that's the certificate I have to use, not the one that is presented by this proxy. Okay. Of course, there are some ways around it. How this works is very similar to instant SSL. You got two services. In this case, an HTTP service, which will basically block, not redirect, block any kind of HTTP request. And then for HTTPS, we'll basically have this new strict transport security policy sent in the response. Okay? Again, you have to have a strong understanding about SSL in order to understand these concepts. Okay? There is a question. Won't it be a problem for the user's browser? Is this regarding PFS or? Okay, PFS. No. Most browsers, most modern browsers know how to handle PFS. They support elliptical ciphers and so on. If you are concerned about Internet Explorer 6, well, switch browser. No, that is not compatible with most things that we are discussing nowadays. So most modern browsers know how to handle PFS. There is another question. Do we need to get all the certificates certified by DCA? Well, ideally, yes. If you don't have a signed certificate, then in that case, you will have a warning in your browser. So ideally, yes. For your web applications, you need one certificate for each HTTPS service that you want to protect. For PFS, you could use an additional certificate, which is not an RSA certificate, but an ECDSA certificate. Okay, so if you want to use PFS, yes, you can use an ECDSA certificate for that. I will show you how to configure this in the web. All right. So how do we configure? Oh, there is another question. How does this affect the performance on the box? Well, of course, HTTPS will have some kind of impact on the performance of the box. But bear in mind that this product is created for this job. All right. So of course, you should monitor the performance of the WAF, but there are many others modules that we will see tomorrow that might impact the performance of the WAF in a greater extent compared to HTTPS. Okay, so let's say worry up to a certain limit. Okay, don't be or don't worry too much. There is a question. So do we do the sizing based on services or the web apps to be protected? This is actually a good question. So how do we size the WAF? How do we choose the correct model? Now, if you open the data sheet of the WAF, you will say that WAF in the capacity part they are sized using the throughput, the recommended real servers, okay, and the HTTP and HTTPS transaction per seconds, okay? So you will mostly hit one of these limits. So transaction per second, throughput, and real servers before you hit the number of services that you configure in the WAF, okay? So of course, each service has an overhead in the web application firewall. But again, you should use what you see in the datasheet to size the WAF. Okay. Also because with the next feature that I will show you, which is called content routing, potentially you can have one service configured in the WAF, and you can have 100 web applications behind this only service. So if I tell you that you should size your WAF in terms of services, that's a lie. I would recommend to size it using throughput and transaction per seconds. And there is another question: how do you compare HSTS with instant SSL? So HSTS is a TLS extension. Okay, it is an extension of the TLS protocol, and it is used to prevent man-in-the-middle attacks, amongst other things. All right, that's its main job. Instant SSL is a type of service of the WAF, so it has nothing to do with TLS extensions. And what Instant SSL is created for is to protect HTTP web applications. So web applications that do not normally use HTTPS. Okay, so by rewriting the web application using the web translation module. Okay, so two different goals. Instant SSL to protect web applications that are not written to use HTTPS, and HSTS to actually prevent that somebody is actually putting itself between your browser and the web server. Does this answer your question? Okay. So at service level, there is another thing that we can configure, which is called content routing. Content routing will allow you to basically specify some rules that will process the traffic based on the information that we have on the request and forward the traffic to some backend servers. So in this case, we have John and Tommy. John is using a mobile phone. Tommy is using a desktop computer. And we have two versions of our web application. One is the mobile web app, and then the other one is a desktop web app. So what is happening is that John is using, for example, an iPhone to connect to this web application. So the service will terminate the request. It will pass the request to the content rule. The content rule will analyze the request and will say, oh, look at that. This is an iPhone. Okay. How does it know it? Because it's written in the user agent. Okay, Safari Mobile and so on. So it will then forward the request to the web server, which hosts the mobile version of the web app. Tommy, on the other hand, is using a desktop computer. All right, so in this case, he's basically using the normal version of the web application. Again, the content rule is going to be engaged, saying, oh, that's desktop computer. I see it in the user agent. I will forward this request to the web server. Okay. Now, let's switch to the live interface, and I will show you how to configure an SSL service. So we go to certificates first. We need a certificate to configure an SSL service, of course. And for this case, I will generate a self-signed certificate. Okay, go to create certificate. Otherwise, you can import it directly in the WAF if you already have it. If you already have a self-signed certificate. And I will create an RSA certificate. We'll call it betstore, betstore.qdiu.org. We can use sans send the subject alternative names if we want for DNS, email, URI, IP. This is normally used for mobile devices. Okay. Yes, of course, you can upload your certificates in the WAF if you already have one. I don't have a valid certificate, so I'm creating one on the fly. This is a self-signed certificate. State Austria, province is Tyrol, and city Innsbruck, and company is Barracuda, and the unit is university. Okay, key size 2048, like normal recommendations. Generate certificate. All right, as you can see now, the certificate has been added into this section. And we can, if you want, you can also generate the CSR to then, this is the request that you have to send to the CA to then sign the certificate. You can also see the certificate, and the private key was exportable. All right, then we go to services. Now, the service name, in this case, is badstore_SSL. Okay, it's an HTTPS service. The virtual IP address, it's going to be the same, 130.140, because we can do this because we are listening to another port. And the real server is 10.1.30.120. Okay, again, this is my bad store, and the certificate is going to be the one that I created in the certificate page. All right, so now I have my HTTPS service. Let's test it. So we actually use HTTPS here. Connection is untrusted. Add exception. Let's check this certificate. Oh no, I'm going to a WASP, to ZAP right now. This is the man-in-the-middle attack. Let's reload. Understand the disks, view certificate. This is my certificate. Okay, Barracuda, university, and the detail of the issuer, Tyrol, Innsbruck. So this is the certificate that I have just created. Okay. And now we are actually accessing the bad store through HTTPS. Okay. Now, wait. Let's go back to the WAF. All right. Let's edit the service. All right. And if we skip basic security, we'll see tomorrow, and we'll go to SSL, we see that if we click Show Advanced Settings, we can enable HSTS. Okay. If we want, we have to specify the max age. This is mandatory, actually. And then we can actually use HSTS for the subdomains, okay, of the domain that we are protecting. For PFS, we just select PFS here to yes. And if you select PFS to yes, you should be able to see, yeah, these are all the ciphers that you can use. And you have the ECDSA, ECDHE ciphers, and so on. Okay. You can also decide to disable, well, SSL 3.0 is disabled by default, actually. Okay, if you want to use an ECDSA certificate, you can then upload it into the system or create it into the system and then select it from here. It's up to you. Okay. Yes, now we have two services on the WAF, one HTTP service and one HTTPS service that are listening on the same port. On the same VIP to two different ports. If you now want to do the redirection, you have to use a function module that is called allow deny rules. But I will not show it to you right now because this is a topic of tomorrow. Okay, you need to create a rule here that will redirect your connection. Okay, so Here you do permanent redirect for the connection to HTTPS. Or the more elegant way, you get rid of the HTTP service, you delete this one, and you create a redirection service. Exactly. So in this case, you create a redirection service, and this will switch automatically to the HTTPS service. All right. Now, for content rules, how do we create content rules? We click on the rule link that we have right next to a service. See, you can add a server or add a rule. If you click rule, the system will ask you the group name. For example, let's call this group Chrome. It's only valid for, I cannot write anymore. Okay, it's only valid for Chrome browsers. Then I can set the host match, the URL match, and the extended match. What are these stuff? What is this stuff? Host match. Now, when you create a content rule, you can define basically when this rule should be applied. For example, in the host match, I can put betstore00.qu.org. Okay, this means that only the requests that have in the host field, remember in the request line, betstore00.qu.org will be processed by this rule. Or I can put anything, all traffic. Same for the URL match. I can put /, for example, payments, okay, or /mobile. Okay, this is the URL, all right? Or I can put anything. And then if I put anything, I have the possibility to configure extended match rules. What are extended match rules? Basically, we go into detail, we dig deep into the request, and we are going to see some information about the request, like the client IP address, the method, get, post, head, and so on. The HTTP version, okay, which version are we using? The URI, the parameter, path info, header, SSL versions, and so on. So let's say that, for example, I want to look for the Chrome user agent. I'm going to put header user agent in the element type contains, for example, Chrome. Okay? Then I'm going to insert this into this header expression field. If I remember by heart how to write it, I can do it. All right? Then I click apply, and then I click save. Okay? Now, I will then need to add a server to the content rule. Okay? Because I'm redirecting the traffic to another server, which is not the service server. Okay? It's another one. So in this case, for example, I can specify that the server name is, for example, dummy. And the IP address I will actually use. No, I cannot use actually anything else. Okay? I will have to specify a server which I don't have. Okay? I don't have any other infrastructure turned on. System is turned on right now. But essentially, this is what you have to do for content rules. Now, when the system is evaluating the content rules, it is first checking the host match. Okay? So whatever you specify in the rules is checked in parallel. So if you have 20 rules, the WEF will take these rules and then will say, who has betstore00.qu.org? If there is a single match, that is going to be the rule that is going to be used. If there are multiple matches, then the WEF will use the URL match field. And again, it will take these 20 rules or the rules that have matched, and it will say who has, for example, /mobile. All right? Again, in parallel, it will evaluate all the rules in parallel. And then it will pick up the rule that has mobile in the URL. Now, if there are multiple rules that have mobile in the URL, in that case, the WAF will start evaluating the extended match rules. Now, extended match rules are evaluated in sequence from 1 to 1,000. OK? So host match in parallel, URL match in parallel. If there is no match, extended match rules in sequence. 1, 2, 3, 4, until the WAF will hit a rule that matches with that request. If there are no rules that are matching with this request, then the WAF will use the service. Okay? Normally, if the WAF triggers a content rule, it means that he has found a match here. Okay, normally it is used the content rule that is as found in the host on the URL match. Is that clear? This is what this slide actually describes, and this is the extended match rules. All right. Is there a possibility to configure a case like this? I will try. Okay, I don't have many systems online actually that I can use for this environment because I only have bed stores and I only have a couple of browsers. So if you want, I can try. We'll note it down. Yeah, but still you won't be able to see it from the browser. I mean, if I redirect the user to bed store number 1, the bed stores are the same. You don't see bed store 1, 2, 3. Okay, so I will find something out. Okay, I will create an environment for this. I'm noting this, and maybe tomorrow I will show it to you. Okay. All right. So do you have any questions regarding? Oh, yes, one important thing. Extended match rules are valid for most of the modules of the web. So it's not just content routing. It can be allow deny rules. It can be URL policies that we will see tomorrow. So whenever you see on the interface this selection, it means that you can use extended match rules. Okay. So as you can see, this is a content rule. If we go to allow deny, you will then see again extended match. If you go to security website, advanced security, you create URL policy. Again, extended match. So you will find this feature basically in many modules of the web, authentication and so on. Okay. So this is the plan for today. We are a little bit not behind the schedule, but for a distance learning course, this is getting too late, okay, to follow all the topics for the distance learning course. So this is what I'm going to do. We're going to do a 15 minutes break, okay? Then we are going to cover the advanced deployment topics, and then we will start the hands-on labs. Okay, so you will have time to do the labs, and I think you are tired, all right? So you will have time to practice and to actually see how things actually work. Okay. So yes, let's start the 15 minutes break. So I'll see you here in 15 minutes, And if you have questions, just ask me questions. I'll be here. Okay. Actually, I will go away for 5 minutes, but then I'll be here. Just type your questions in the chat. Yeah, go ahead. If you have questions, you can ask me right now. I will stay here.